Yeah, welcome to the first live session on the course system design through VLS, Verilog. So there are some questions like what are the basic requirement to get internship in VLSI? So here basically you have to contact the professors who are working in this VLSI area. If professor is willing to provide the internship, then he can take. There is no other requirement. Actually, you have to show that you are interested in this VLSI area, and if you did some projects based on the VLSI, you can highlight those projects and all in your CV. You just forward your CV to the professors who are working in VLSI area. If they are interested, they will take. Coming to the second question, in the switch level modeling. So the correct the order is first source, drain, and then followed by the gate. PMOS or NMOS. So in general, this is PMOS, output, comma data, control. So the out is correspond to source, data is correspond to drain, control is correspond to gate. Even in case of transmission gates also, the same strategy will be followed. But in case of transmission gate, this is instead of PMOS, NMOS, that is CMOS, and we'll be having same output data, but we'll be having two controls, in control as well as P control. So in the gate level modeling, how the compiler knows? Actually, we have to define this ports as input or output port. For example, if you have A, B as inputs and Y is the output. Then you have to define input, this is port declaration, A comma B. Output Y. Then the compiler will take AB as the inputs and Y as the output. Video downloading, you can contact the some contact person is email ID will be given in the I think website. You can contact that person. And there are some questions in forum. Most of the questions actually has already answered. So in some questions it is written that why this RP is less than Rn. In case of pull up or pull down, I have given one circuit. This is pull up resistance. Then we have three pull down resistance, pull down I mean transistors. This is connected to ground. This is a ABC. Here we are going to take the output Y. This is basically this is NOR operation. This is VDD. If all these three gates are off, A is equal to B is equal to C is equal to 0, implies transistors off. Acts as open circuit. So the output will charges to VDD. This is RP. So output V becomes almost VDD with a small drop across this RP. RP normal will take as a lower value. So this output will be VDD. So in the other case, if any one of the input is 1, if say A is equal to 1, then what happens is this will be having some on resistance. Ideally speaking, ideally this A is equal to 1 means this will be A acts as short circuit. Short circuit in the sense resistance is 0. This is ideal case. But practically there will be some small resistance is there. This is of almost a 0. So when compared with this RP, this Rn is almost 0. In case of a short circuit, sorry, Rn is infinite. Rn is 0. So Rn is almost 0. So if you want to get the output, so there is a VDD, then this is Rn, this is Rp, Rn is less than Rp. So it will be the output, this is VDD, VDD into Rn by Rn plus Rp. So Rn is much less than this Rp. Okay. So Rn is much less than means you can neglect about this one. So this is smaller value, this is larger value. So this is 10 ohms, and this is 10 kilo ohms. So what will be the output? VDD into 10 by 10,000. It's almost 10 to the power of minus 3 into this. This is 5 millivolts. This will be taken as logic 0. If any one of the input, this one is short circuited, A is equal to 1. This is non-operation, Y is equal to A plus B plus C whole bar. If any one input is 1, 1 plus anything is 1, so 1 bar should be 0. So that is how. So here this Rn should be less than Rp. If you have given Rn greater than Rp, you can change that. Rn should be less than, because so whenever it's on, it will act as short circuit, means ideally 0 resistance. Practically there will be very small resistance. So there are some doubts based on this in forum, and there is one more doubt like strengths. So strengths will be actually if I pass the signal through the resistances. Okay, this is S1. This is S1, this is S2, S3. The R1, R2. S2 is less than S1 because there will be some drop across this R1. So like that. So what is the signal strength? How much reduction in the signal strength is allowed without changing the circuit operation? Suppose if this is at logic 1, after this 2 resistance, if you get logic 0, then it will give the wrong operation. So even if this logic 1 has been changed to say high, so still this will be taken as in the slides actually have explained the type. If it is capable to drive this output, then so that much change in the resistance is allowed actually. That is why the highest priority is for supply 1. Supply 1 will be taken as logic 1. Even the next signals, I don't exactly remember the order. The next signal, 3, 4 signals, still this signal will also be taken as logic 1. So even if I reduce this voltage drop from supply 1 to the next signal, or even the next signal, even next signal, still that will be taken as logic 1. That is the idea behind this signal strengths. If you have any other questions, you can ask. Yeah, the thing is for the complex problems, actually, sometimes it becomes difficult to write the Verilog code. So the people, what they will do is, especially the computer science people, they will write the C code and they will convert using HLS. Okay, but optimum, if you want to talk about the optimization of this program, then writing in Verilog is very optimum. Always, it's a good practice to write using Verilog instead of going for the C and converting into the HLS. It's always good practice to write Verilog, because the Verilog, if you write, you can optimize the problem. So finally, if you want to fabricate the IC, you can come out the IC with less power, less area, and high speed and all. In HLS, actually, you will not consider those things actually. So especially the computer science background people, they prefer HLS, and electronics background people, they try to write in Verilog. But if it is very complicated, then we'll go to the HLS. Especially in case of convolutional neural networks, nowadays we have artificial neural networks implementation using VLSI. Then in that some operations are very much computationally intensive. So people are preferring HLS there.
Hello. Hello, sir.
Yeah, hello.
Sir. Sir, I just want to download the video, but I'm not able to do so. That
So you contact some the persons, like in case of IIT Guwahati, Kallal Barua is there. You can write to him. He will help.
Kullan Badua. Okay,
Huh.
sir. Sir, actually, in earlier course that I have actually done in the previous semester, in that cases, all the videos there, and I just
Actually, this actually I recorded 3 years back. The same thing is rerun. Means there will be no recording. If you did this course in the last year, means the same contents will be there. Only question paper will be different.
That's true, sir. No issue. What I'm saying, in the download section, if all the video can put, then from there on I can actually download in the download section, because it could actually become
that is actually not related to the academics, no. So actually I'm not aware of that one.
Okay.
You contact Kallal Barua.
Okay, sir.
Because
Okay,
that things will be taken care by the other project staff committee. So professors will not do this, all those things.
Okay, sir. Kullan Badua. Okay, I can. Sir.
Yeah.
So is it available in the IIT Guwahati website, sir?
Yeah. Otherwise, also in IIT Guwahati CET, you can go for this centers, Center for Education Technology. So in that, you just see the staff members, various staff members with photograph, their email ID, everything will be mentioned.
Okay, sir. Okay, sir. Okay. So my second question is, sir, actually the second assignment 2 first question, the propagation logic, actually.
Can you tell that question? Actually, I don't remember.
Yes, sir. It's the question.
Can you read the question?
The question is, sir, which gate is used to implement the carry propagation in a replica adder?
There is a mistake. We are going to correct that.
Okay, sir. Okay, sir. So I have actually or gate should be the answer, right, sir?
Yeah, correct.
Okay, sir. Okay, sir. That please do. Okay, sir. Okay. Thank you, sir. Thank you.
Yeah, thank you.
Good evening, sir.
Good evening.
I wanted to ask a question on 3-input NMOS NOR gate. There was a prerequisite in there, like pull down resistor is supposed to be greater than the pull down resistor is supposed to be greater than the pull up resistor. This was the prerequisite. I quite did not understand it. Why is the resistance is affecting how which level is going to the output, like 0 or 1?
Yeah, reason is actually if I take NMOS, the majority carriers are electrons, right? And in case of PMOS, majority carriers are holes. So the mobility of electrons is greater than the mobility of the holes, right?
Okay. Yeah.
So because of that, the NMOS will be having more speed when compared with the PMOS.
Okay, sir. Okay. And sir, one more question.
Yeah,
In
please.
8 into 2, 8 into 2 ROM, where we are using 3 into 8 decoder. So what I'm not able to understand is how are we giving the input in the registers to store what bits are to store bits in D1 and D0. So I did not understand how the ROM matrix is working. Like we are giving their OR gates and what input are we giving there? What deciding? मतलब क्या चीज डिसाइड कर रहा है इस चीज को?
Okay, I'll explain. So basically, if we take 8x2 ROM, means there are 8 locations. 8 locations. 0, 1, 2, 3. This is 0th location, 1 location, 2, 3, 4, 5, 6, 7. Each location is capable of storing 2 bits of information. This can store 2 bits. Totally, we have 16 bits of information can be stored in 8x2 ROM. So this each bit can be 0 or 1. So we require this is 8 total locations. So this 8 can be written as 2 raised to the power of 3. So we require 3 inputs, 3 to 8 decoder is required. In order to construct 8x2 ROM, a 3 to 8 decoder is required. So the first value you have to express as a power of 2. Whatever that power is there, that is the number of inputs for the decoder. And we know that decoder will be having n inputs and maximum outputs will be raised to the power of n. So there will be a 3 to 8 decoder here. Say x2, x1, x0. And there will be 8 outputs, y0, y1, so on up to y7. What we are going to do is, we are going to connect here 8 input OR gates, 2 8 input OR gates. The inputs are y0, y1, y2, all y7. Similarly, for the second OR gate also, the inputs are all y0 to y7. So these are the outputs. Suppose if I want to write, say any location, 10 location, 100 location, 8 locations are there, 3 bits. In y0, 100 means this is 4th location. If I want to write 10, say, means whenever if I give here x2 is MSB and x0 is LSB, 100. So I have to write here 1 and 0. For 101, what happens? Only this is 100 is y4. So y4 will be 1. Output y4 will be 1. Remaining all will be zeros. So here, if I take this OR gate with 8 inputs, this will be connected through fuses. Like in electricity department, we have fuses. in our house wiring. So if I give 1 0 0 0, out of these 8 outputs, Y0 to Y7, only Y4 is equal to 1. If I take this as OR gate 1, O1, this is O1, this is O2. So I want the output of this one should be 1, means I will intact this Y4 connection. Y4 connection, say this is Y4. This connection will be intact. I will not break this connection. Then the other connections, even if you do break also, it does not matter. For OR gate, if one input is 1, output is 1. Whereas in the second OR gate O2, I want the output as 0. If I keep all the inputs intact, this is O2 gate. If I take all the inputs intact, Y0 intact, Y1 intact, Y2 intact, Y3 intact, Y4 intact, Y5 and Y6, Y7. What will be the output? Because Y4 is equal to 1 for X2 is equal to 1 0 0, Y4 is 1, this is also 1. But I want to store 0. So what you have to do is, if I break the connection corresponding to Y4, so for this gate, whatever this Y4 connection is there, if this is a Y4 connection, what I will do is, this I will break. So what happens, output is, the line where output 1 is coming broken, then the remaining all our inputs output are zeros, output is 0. If you want to store 1 bit, you have to keep all the fuses intact. If you want to store 0, so it depends upon this, the combination. Whichever the output is 1, that corresponding connection has to be, you have to blown that connection. You have to break that connection. Then output will be 0. Is it clear?
Okay, sir. Then these OR gates are actually being used for storing the data, right?
Yes, yes, exactly.
Okay, sir. Not accessing them. We are storing here.
Not accessing. If you want to access also, you can directly take from here. Already it's there for reading, actually no problem. Writing is actually, this procedure is for writing. Reading is already output of this gate is one is there that you can read from by using either LED or any other device.
Okay, sir. Okay, sir, I understood. Thank you.
Yeah. Any other doubts?
Sir, I just wanted to ask one more thing, last thing. In the 3-bit synchronous counter, we are making using JK flip-flop.
Yes, yes.
When we are designing the K map, why are we using the previous state output, not the next state one? Like when we are looking for the don't care condition, or when J1 or K1 is high for making the K map, why are we only looking at the previous state? Why not the next state when we are making the K maps?
Actually, we are using the this transition table, right? Transition table. So in that, actually, if present state is we can follow two notations. One is present state next state, or present state previous state next state. Okay. So Qn to Qn plus 1. Is it visible?
Yes, sir.
So actually in excitation table, I want to change it. So Qn to Qn plus 1. Either you call this one as, if I call this one as a present state, this is next state. If I call this as previous state, we can follow any notation. Then this will be present state. So if I want to keep this 0, then what are the J and K required? 0x. If I want to change from 0 to 1, what are the inputs required? 1x. If J is 1 and K is regardless of 0 or 1, I can change the output from 0 to 1. Okay. So in the table also, if I write the present state, next state, flip-flop input functions. 0, 0, 0, I want 0, 0, 1. This is Q2, Q1, Q0. This is Q2, Q1, Q0. So I want Q2, I have to keep as it is. So corresponding J2, K2 will be 0x. Q1 I want to change, I want to keep as it is. So J1, K1 is also 0x. Q0 I want to change from 0 to 1. So 0 to 1 means 1x. Previously some state is there, but after application of the clock signal, I want to change the state. So that is why you have to see the what are the changes. This you have to keep 0 as it is. This you have to keep 0 as it is. This you have to change from 0 to 1. Accordingly, this is J2, K2 is 0, 1, 0x. J1, K1 is 0x. J0, K0 is 1x. Is it clear?
Yes, sir. By the way, sir, your course is very, very good, very informative. I really liked it. This was the first time I was studying Verilog. Actually, we were not taught in our college. So I looked into the NPTEL and started my VLSI journey from there. So I also took one more course in RTL to GDS one. So sir, do you have any recommendation? What should we do next? Like after I finish this Verilog and the flow of VLSI RTL to GDS, what should be my next step to get into the physical design domain?
Then you can go for some architectural courses are there. If you want to work in digital area, actually in VLSI there are 3 areas again: semiconductor devices, analog, digital. So if you want to work in the digital domain, then you can do some architectural course, architectural design of ICs, digital IC design course is there in NPTEL. So in digital design, starting from this algorithmic level to architectural level, then architectural level to gate level to again transistor level, then layout. Finally, you can fabricate the IC. So this also I have discussed in the one of the lectures. So you have to take the courses correspond to one architectural level. Gate level is anyhow you might have studied in digital circuits, and transistor level also you might have studied in. Even here also I have covered some transistor level, and then finally you have to find out how to draw the layout of the circuit. So once if you know the layout, then you can work on the IC fabrication also. If you have some knowledge in IC fabrication, then a lot of opportunities are there.
Okay, sir. And is risk architecture related to this field? RISC-V, I'm hearing a lot of news about it since it's open source and all.
RISC actually is one sort of the microprocessor only. Nowadays, the IIT Madras has developed one RISC processor. So in that, basically, we'll reduce the instruction set. Normally, if I take the general microprocessor like 8085, 8086, lot of instructions are there. So in order to code those instructions, lot of hardware is required. In case of RISC processors, actually reduce the instructions are very few. But the corresponding hardware will be fabricated in this IC itself, means that processor itself. So instead of having the software instruction, if you have the hardware unit of that particular one, say for example Mac operation, we can have an instruction for the Mac. Instead of that, if you have the Mac hardware, then it will be more faster than the software instructions. Okay. So that type of logic is employed in RISC processors. So once if you know this, the basic digital design, this Verilog also you can implement those RISC processor also you can design. So in order to design any digital circuit or digital processor, so you have to first verify that circuit behavior. For that you can use Verilog and you can check by using FPGAs and all. Once if your functionality is correct, then you can go for the fabrication.
Okay, sir. Thank you for your advice.
Thank you.
Excuse me, sir.
Yeah, please.
Yeah, I wanted to ask you if I want to contact you afterwards, maybe sometime in the future, during after my BTech. Is there any way I can get your contact or maybe email ID, something?
Yeah, email ID. My email ID is there in my website also.
Okay. Just for guidance purposes, I just needed it.
I'll write out uppercase letter, but all are lowercase letters only. All are lowercase letters.
Okay, sir. Thank you. Okay, sir. That sums it all. Thank you. I'm good.
Okay, thank you. Good luck. Because the time is limited. If you have any queries, you can ask actually. I have another lecture at 4 p.m. also. Yeah, you can appear for the gate. So gate is mandatory now for MTech. Without gate means if you employed in some company or some industry, then they can sponsor. There are some sponsored seats also there. For that, gate is not required, I think. But if you want to get the direct MTech seat, then you have to appear for the gate and you have to secure the good rank.
Hello?
Yeah, please.
Can you explain the procedure of exams, sir?
Sorry. Can you repeat?
Can you explain the NPTEL examination process, sir?
Okay. Examination is actually, I think nearly some 30 questions or 2 marks questions directly. Object to type, all object to type. And the remaining 40 marks questions will be given some data, common data. Based on that, you'll be having 2-3 questions. Like a Verilog code will be given, and you'll be asked to. There are some 2-3 instructions will be skipped. You'll be asked to fulfill those instructions. Any other questions? Both are almost same only. So some of the industries will use Verilog, some of the industries will take VHDL, but most of the things are common. The only the primitives that we are going to use, like and or, so there will be some difference in that, I think. Normally I use only Verilog only, so I don't have much knowledge about VHDL, but they are similar languages only. Yeah, exam pattern is, I think there are some 30 questions of 2 marks each, objective type. So direct questions. Then 30 into 2, 60 marks, and the remaining 40 marks is, I think I have given some common data. Will be given some Verilog code, uh, sometimes with some missed instructions. Some this I mean some instructions will be deleted, or it will be put a dash, or in some of the primitives, some data is missing. So you'll be asked to find out those missing data and all. That type of questions, remaining 40 marks. Yeah, good afternoon. Do you have any questions? If you have any questions, ask quickly. Actually, I have another lecture at 4 p.m. Thank you. So the missed tutorials, how to contact, because that tutorials will be conducted by PMRF research scholars. They are not in IIT Guwahati. They are from other I think IIT Tirupati. So you just mail me. I'll try to provide you that missed records.
Hello, sir. Good afternoon.
Good afternoon.
Sir, actually, my question is in Verilog code, we will use parameter to define the constants, right?
Yeah.
Yeah. Actually, why we will use that parameter? Directly, we can assign a constant, and that's it, right? Integer is equal to width is integer width is equal to 13. Like that, we can define, right? Why
Actually,
we go
that
for
designer,
parameter?
the designer has designed in that manner only that code. So that depends upon the designer. So he will have seen many of these things in his mind while designing the code. That is actually the gateway system who has developed this Verilog code. They would have done some research and they found that this type of main declaration is more efficient in terms of power consumption, in terms of energy and all. That they would have done some research on that one. Finally, they have developed this Verilog language.
Yes, sir. Understood. Thank you.
If you don't have any questions, then I'll take the leave because I have one more lecture at 4 p.m. So thank you for your active participation. If you have any doubts, also you can send me the mail, or you can write in the discussion forum. I'll answer. Thank you. Good luck.
Thank you, sir.